Since you don't know about the name of this sir also, who is this sir? I'm your math faculty. Okay, so I'll teach math up to your new senior faculty reported here. Okay, I think by this week or next week he'll come and report. Okay, so it's a temporary adjustment of math class. Okay, now. So may I know from any one of you the definition of relation? Hmm? Superb. Subset of Cartesian product. Okay. Can you elaborate? When you are learning about relations concept, I hope you learned about the definitions of domain and range as well, isn't it? Then by using the words domain and codomain, can you give the definition of relation? Any element in the domain can be mapped to any element in the codomain. Is called a relation, isn't it? So after knowing about the relation, we have to learn about function. So function is also one of the type of a relation because function definition itself is defined as each and every element in the domain should be mapped with unique element in the codomain. What is its definition? Each and every element in the domain should be mapped with unique element in the codomain or exactly one element in the codomain. That is called the definition of a function. So as I told, function is also one of the type of a relation. Then what is the difference between relation and a function? After knowing about the definitions, I think you have identified the difference. Relation definition means any element in the domain can be mapped to any element in the codomain. Function definition means each and every element in the domain should be mapped to exactly one element in the codomain. Okay. Now the difference between relation and function is all elements should involved in mapping for a function. Okay. But for a relation, you can leave few elements without mapping in the domain. You can leave one or two elements. That's about the type of relation. Okay. So from this, what you can say, all functions are relations, but all relations are not functions. Remember this point. This is very, very important. Okay. Now I'll ask you to write the definition of a function. So mathematically, you can give the definition of a function like this. So f is said to be a function by following a rule assigning exactly one element y in set B to one element, each element x in set A is called mapping or a single valued function from A to B. That is a mathematical definition. Or you can write like this also. With the help of domain and codomain, you can write function definition like this. Each and every element in the domain, each and every element in the domain should have unique image in the codomain. Unique image in the codomain. So this is called a function. You can write like that. Copy the definition. I think you know domain and codomain means domain means the values which we are giving to the function, isn't it? Input values. Codomain means the values in set B. Set A elements are all called generally domain values. Set B values are all called as codomain values. And there is a difference between codomain and range. I think this point also told by ma'am while explaining relations concept. Can anyone say the difference between range and codomain? Codomain means a set of values which are in set B, isn't it? So to say a relation between two sets, we should first require two sets or not, set A and set B. So in set B, the set of values all together called as codomain. Then range means the elements which involved in mapping. The elements which involved in mapping in the codomain are called range. Okay. So range and codomain both are different again. Remember that. Okay. So here function should be function from A to B should be written as f from A to B. So we need to write f from A to B. Here this colon should be semicolon should be pronounced as from. Okay, f from A to B. Here A is called domain and B is called codomain. So just write like this here. F from set A to set B. Like this we need to pronounce. Function related from set A to set B. Keep remember, generally in domain, the input values are from x-axis. Are from which axis? X-axis. Output values are from which axis? Y-axis. Remember that point also. So I already told function is also a special type of a relation. Okay. So function is also called as a relation, one of the type of a relation. So let us see few examples of the function. F of x is defined as x plus 5. I'm going to consider set A elements and set B elements as set A elements as 1, 2, 3, 4. Then tell me, as per this function f of x, what are the elements we will get in codomain as outputs? 6, 7, 8, 9. And it may contain 10, 11 also. 10, 11 are unmapped elements. Then what are the mapped elements? 6, 7, 8, 9. And hence you can call the a range of this function as 4. You need to say the cardinal number as range. What is the range of this function? 4. So if you want to say codomain, you need to say all the elements in set B. If you want to say about range of f, then you need to speak about the mapped elements alone. That is the difference between codomain and range. So here this is called a codomain. Okay, and the domain is called set A elements. Just simply you can write 1, 2, 3, 4 here. And function from A to B is defined as x plus 5. You can write this as an example. Note down quickly. Finished? How many of you are carry forward students here? Once raise your hand. Carry forward means already studied 11th year and entered into 12th. Raise your hand. Very good. New students, once raise your hand. 1, 2, 3, 4, 5. Yeah, new students count is less. Carry forward students count is more. Very good. So I'm moving to next point. Put the side heading graph of a function. Students, just now I took one example. What is that example? F of x is equal to x plus 5. So f of x is equal to x plus 5. As I told, all x values should be considered as domain, and all f of x values are called output values. Which type of values they are? Output values. So x values are all called input. F of x values are all called output values. So output values should be always there in which set? Codomain. Okay. Output values are always there in codomain. So input should come from x-axis. Output values are from y-axis, I told. Isn't it? So I can take f of x as y or not. Since we are considering output values are from y-axis, so f of x should be considered as y by default. So I can equate f of x to y, so I can write y is equal to x plus 5. So tell me, y is equal to x plus 5 is a linear equation in two variables. The graphical representation is a straight line. Yes or no? So if you represent this line in the Cartesian plane, so then what you'll get? Minus x plus y is equal to 5. So x-intercept a negative, y-intercept a positive. So you will get a graph like this: 0, 5 and minus 5, 0. Says or no, students? So once you plot the graph of minus x plus y is equal to 5, you will get a graph like this. So this is y-axis and this is negative x, positive x. Okay. So this is the graph of the function y is equal to x plus 5. Now remember, students, there is one approach to identify whether the given functions, whether the given mapping from A to B is a function or not. So whatever the relation from A to B, whatever the relation it may be, you can draw its graph, isn't it? You can draw that relation's graph. Once you draw the graph, there is an approach to identify whether that relation is function or not. Okay. So in that approach, we will draw a vertical line, and that vertical line should intersect the graph exactly at one point. A vertical line in the sense line which is parallel to y-axis. Okay. That is actually the procedure to check whether the given relation is a function or not. We know that here this is a function. So just draw one vertical line parallel to y-axis and check whether that line is intersecting the given graph at exactly one point or not. If it is intersecting exactly at one point, then it is a function. If it is intersecting more than one point, means 2 points or 3 points like that, it is not a function, it is a relation. Okay. So that is the graphical approach to identify whether the given relation is a function or not. So here in this graph, I just want to draw a vertical line. At how many points that line is intersecting the graph? 1 point. So obviously it is, tell me students, function. So y is equal to x plus 5 is purely a function. Okay. All functions are relations, but all relations are not functions. Remember that point. So note down this graph as well. Put this heading graph of a function. Just note down that graph and just make a note. For every function, a vertical line drawn parallel to y-axis intersects the graph exactly at one point. You have to copy this point. Yeah. So I just want to take one more example, students. Meanwhile, this is example one. Example two, I just want to consider f of x is equal to x square, or simply you can write y is equal to x square. So y is equal to x square is a parabolic in shape, isn't it? So it is which type of parabola? Upward parabola, whose vertex is horizon. Have you gone through conic section in 11th standard? Have you gone through parabola concept? Then y is equal to x square is an upward parabola with vertex 0, 0. So you'll get an upward parabola like this. Okay. So this is y is equal to x square. This is x axis. This is negative x, positive y, negative y, horizon. Now tell me, students, if I draw a vertical line, then that line will intersect this graph exactly at how many points? 1 point. Then y is equal to x square is also a function. So just note down the second graph as an example. Finished now? Shall we move to the next point? So yeah, let us see these examples. Here three graphs they given. Tell me among the three, which one is a function? I think all are relations. Because when you are drawing a vertical line, it is intersecting the graph at more than 1 point, which means 2 or 3, whatever it may be. Here 2, here also 2. Isn't it? So obviously, all these are relations, not a function. Okay. That means what is your observation from these graphs? One element in domain is having two distinct images in codomain. That is not the property of a function, yes or no? Each and every element should have a distinct image in codomain. That is the property of a function. If a single element is having two images in codomain, how it would be a function? So obviously it is not a function. And we are giving the graphical approach of that definition. Okay, keep remember the basic point. And now you have to copy these rules, students. So rules for finding domain of a function. So these rules you have to copy. I will explain one after the other. Listen carefully. So any function which is under square root or cube root or fourth root, okay, like this, then definitely x must be either 0 or greater than 0. Okay, x must be either 0 or greater than 0. That is a rule. Remember that. For example, if any function is there in denominator, x variable is there in denominator for the function. Then how to find the domain? So the denominator value should not be equal to 0 to make the function defines finitely. To make the function defines finitely, what I'm doing? I'm not equating the denominator to 0. If denominator becomes 0, what happened? Tell me, students. That entire function become undefined. So to make the function defines finitely, I'm not equating the denominator to 0. So this is another important point. For example, you may get it out. Sir, if a function contains a square root in denominator, what I need to consider? Very not equal to, strictly greater than 0. You have to consider x must be strictly greater than 0. Okay. And there is one more rule. Any two functions f of x and g of x either added or subtracted. And this function, two functions we are clubbing together by adding or subtracting. And we are getting one more new function called h of x. If they asked us to find the domain of h of x, you need to find individual domains of f of x and g of x and consider the intersection, common part of both domains to say the domain of h of x. Okay. So f of x and g of x either added or subtracted. If two different functions they given, then what you need to do? You have to find f of x domain separately, g of x domain separately, and consider the common interval for both the domains. Okay, then you will get domain of h of x. And this one, any two functions divided with each other, f of x and g of x are divided with each other. Here also find the domain of f of x, domain of g of x, and find the common intersection of d1 and d2, and subtract for what values of x, g of x becomes 0 from this intersection part. So if g of x becomes 0, then this entire f of x by g of x become undefined or not? Isn't it? We are doing the same thing what we did for h of x, but which values we are subtracting? The values of x which makes g of x as 0. Those values we are subtracting from d1 intersection d2. I hope you got my point. Yes or no, students? So then you may get it out, sir. You told about addition, subtraction, and division. What about multiplication? If f of x and g of x both are multiplied, you will get one more single function, isn't it? Then you can directly find the domain of that single function. So that's why multiplication case I omitted. Understand? So these rules you must have to copy, students. Along with these rules, I'll give you a few more. So there is a function called log x. Tell me, students, to define this function log x finitely, there is a condition. What is that? X must be greater than 0. Okay, remember this. There is a function sin x, all trigonometric function domains you know, I think. What is the domain of sin x? Domain of sin x. All real students, x can take any real number. You are saying range of sin x. X can take any real number, but sin x should alter always in between -1 and plus 1. Okay. You are saying output values. I'm asking for input values. So domain of sin x is all reals. Domain of cos x, all reals. Domain of tan x, all reals except multiples of pi by 2. Because at the multiples of pi by 2, tan x become undefined or infinite. You can use infinite. So clear are these points? So while you are learning trigonometry, you have already gone through domain and range. Actually, after knowing about these points, then if you learn about trigonometry, domain and range concept, it is so easy for you. But there is a usage of trigonometry, and in the flow, we were supposed to thought the domain and range of trigonometric functions as well. Okay, so shall we do a few examples? Have you copied these rules? If you want, you can copy quickly. I'll move to example questions. Rules are also very important. Finish down, everyone. Shall I move to the examples then? Because we are writing more down. I'm giving time on. What you are doing. Yeah, book if there I can. If you write the content from book, then only it will register in your. Okay. Yeah, just try it. I'm saying the outline part only. In book, precise content is given. Yeah, you can read in home also. But why you are coming and learning here? Just to register those points in mind, isn't it? For that you have to. Everyone were writing our notes, sir. Write down, students. Okay, I'm moving to examples. So see this question. It's a basic question. So there is a set A. 1, 2, 3. The elements in set A are 1, 2, 3. Determine which of the following relations over A is a function. He already given A to A relations. So among these four relations, which one is a function? So you can consider B and C. Very good. Why B and C? 1, 2, 3 are domain elements, which are having a distinct image in codomain, isn't it? 2, 3, 1. Here, 1, 2, 3 are domain elements. All domain elements we considered, isn't it? 1, 2, 3. Only 3 elements are there in domain. All elements we considered, which are having distinct images again, isn't it? In codomain. But here, 1 we consider 2 times, so it is not a function. Here, 1 is mapped to 1, 2 is mapped to 2, but 3 is unmapped element. If 3 is an unmapped element, that is also not a function. Okay, so all elements should involved in mapping. So only B and C are functions. Yeah, see this example. Which of the following graphs represents a function? A and very good. If you draw a vertical line here, it will intersect at one point. If you draw a vertical line, it will intersect at one point. But here, more than one point. Here, more than one point. So this is a function. These two are functions. A and C are functions. B and D are not functions. Yeah, I was asking domain of f of x is equal to x minus 2 by x square minus 4. Very good. You have done this question already. So very simple question, students. As I told you, the denominator value should not be equal to 0. Then here what you will get, x square is not equal to 4. Then x is not equal to plus or minus 2. Then x belongs to all reals except plus 2 and minus 2. Okay, clear? See this question. What is the domain of this function? It is under the square root. So students, x minus 2 into x plus 3 by x square minus 4. Since this entire fraction is under the square root, can I put greater than or equal to 0? Since that fraction contains denominator, can I write this condition as well? X square minus 4 not equal to 0. Can I write this condition? Then x square not equal to 4, x not equal to plus or minus 2. So this is one condition. So if this entire fraction is positive, then definitely what you can say? X minus 2 into x plus 3 is also positive. Denominator and numerator both should be positive, isn't it? So I can consider if both denominator and numerator both are positive, then also you can say entire fraction is positive. Both numerator and denominator both are negative, then also you can say entire fraction is positive. But among these two, which condition you have to consider? Which condition you have to consider? Both conditions you need to consider, and you need to consider the intersection part. Okay, so in that you will get x minus 2 into x plus 3 greater than or equal to 0. Then what you can say x belongs to? Students, I hope you are all aware of this relation. This is very, very important inequality. X minus alpha into x minus beta greater than or equal to 0 for alpha less than beta case. What you can say for the values of x? X belongs to sign scheme method. I hope you already learned sign scheme method. So x belongs to, tell me students, minus infinity to alpha closed interval union closed beta to infinity. This method, I hope everyone know. If you are not aware of that sign scheme method, then tell me, I will explain for you once again. How many of you want? Yeah, just listen. Very simple, students. As per ascending order, we need to consider alpha and beta in the number line. Okay, as per ascending order. Then after, check the power of x minus alpha and x minus beta, and check the leading coefficient as well. Leading coefficient in the sense x square coefficient. It is the product of two linear factors, yes or no? X minus alpha and x minus beta. If you multiply x minus alpha and x minus beta, you will get a quadratic expression. In that quadratic expression, x square coefficient is called leading coefficient. Check its sign. Here x square coefficient is 1. 1 is positive or negative? Positive. So if you are having a positive leading coefficient, you have to put sign positive over the number line. You have to start positive over the number line. And when you are crossing alpha, check the power of x minus alpha. If it is odd power, change the sign. What is the power of x minus alpha? 1. 1 is odd number, even number? Odd. So change the sign. Next, you are crossing beta. While you are crossing beta, check the power of x minus beta. If it is odd, again change the sign. So again it is odd. X minus beta whole power, what it is having? 1. 1 is an odd number. So change the sign, plus sign. Now, just consider this is minus infinity, this is plus infinity. So you are considering the region in which x minus alpha and x minus beta both are positive. So definitely the interval you need to consider here was minus infinity to alpha. Since greater than or equal to was there, you have to include the extremities alpha and beta. And hence I'm using which bracket here? Closed bracket. Union, another interval has positive region, that is from beta to infinity. If I ask for the same function lesser than or equal to 0 for what values of x, what you will say? So x belongs to closed interval alpha comma beta. So I hope you know the concept. While you are writing intervals, always you need to consider lesser value in the left hand side, larger value in the right hand side. Follow these rules, okay? So if you are writing beta comma alpha, that interval is wrongly denoted. Remember that. So always you have to write lesser value in the left, larger value in the right. As per number line, you need to mention the intervals as well. Okay. In number lines, lesser values on left hand side, larger values on right hand side. So in the same way here also, then you may get it out. Sir, you told with x minus alpha and x minus beta, but here plus sign is there. What I need to do? So just rewrite this x plus 3 as x minus of minus 3. And this is x minus 2 greater than or equal 0. Now tell me in the explained conceptual part, instead of alpha, we are having minus 3 or not? Instead of beta, we are having 2 or not? Then x minus alpha into x minus beta form we formed. Then obviously from this you can easily write x belongs to minus infinity to minus 3 closed interval union closed 2 to infinity. Yes or no? So this is the interval we are getting for this condition. And for this condition, x should not be equal to plus or minus 2. But here plus 2 we are considering. As I told, we are not supposed to consider plus 2. Then what we need to do? Union closed interval 2 to infinity. So here instead of using closed, consider open. So another case is there. What is that? X minus 2 into x plus 3. If this become negative, if numerator become negative, denominator again it should become negative. Says or no? If numerator is negative, denominator should be negative. Then only negative cancelled and entire fraction becomes positive. Now tell me in this case, what you will get? X belongs to closed minus 3 to closed 2. But this is common to both the cases, students. Anyway, it is in denominator, no, x square minus 4. That is common to both the cases. So here also x should not be equal to plus 2. So I need to consider open interval here. Okay, I need to consider which interval? Open interval. Now tell me, in this case, from minus 3 to 2 open interval, minus 2 is included or not? Minus 2 is included or not? Included, no? From minus 3 to plus 2 open interval, minus 2 is included. That value also we need to subtract. That value also we need to subtract. Now tell me, in either cases, in the first case, this is the value. In second case, these are the values of x. Now, from these two, can you say the common part? Is there any intersection part? No intersection, isn't it? Just consider values of x in between minus 3 and 2. Just consider any value. Minus 3. If you consider minus 3, check the function whether it is defined or not. Here minus 5 and anyway this will become 0. Minus 5 into 0 divided by, and what about this? This will become, so if you consider minus 3 in denominator, what you are getting? Plus 9. 9 minus 4 how much? Plus 5. Okay. Even though if you consider some minus 2 into here how much? Plus 1. In denominator, if you consider, so we are not supposed to consider minus 2 as well. If you consider minus 2, this will become, denominator becomes 0. And consider any other value. Minus 3 we considered, minus 2 we consider minus 1 as well. And check once. This will become minus 3. this will become 2, and minus 1 if you consider, denominator become negative. Negative cancelled. So under the root you are getting a positive result, which is root 2. Root 2 is a finite value. So there are some values which are defined in this interval and in this interval as well. So you have to write x belongs to minus infinity to x belongs to all reals except minus 2 and plus 2. So what is the union of these two interval, students? What is the union part? I am taking union part because in this interval there are values of x which satisfies f of x. In this interval there are values of x which satisfies f of x. So you have to consider all the values of x as domain except the values which are not satisfying. Here minus 2 it won't satisfy, and plus 2 we are using open brace. So we have to exclude minus 2 and plus 2. Okay na? Clear, students? This one, yeah, tell me. This one, when you are changing function, then you are restricting domain. We are not supposed to change the function. Remember, while they are asking, so such type of questions, don't change the function while calculating domain. Okay. So I given one more question. So in this example also you can clearly observe x minus 2 by x square minus 4. Denominator you can write x plus 2 into x minus 2. Say yes or no. X minus 2, x minus 2 you can cancel. But I didn't cancel. Reason? If you cancel like that, you are getting restricted domain. Which type of domain it is? Restricted domain. He was not asking us to find that domain. He was asking us to find domain of this entire function. So that's why you are not supposed to simplify. And in the same way here also you are not supposed to simplify this. Leave it as it is and simplify and find the domain. Okay. Yeah. Shall we move to another example? Yeah, see this question, students. Here, f of x is given as log of x square minus 7x plus 10. Tell me, since the function is in the logarithm, what is the condition? X square minus 7x plus 10, this should be greater than 0. And what are the factors of this quadratic polynomial? X minus 5 and x minus 2. Now tell me. So I'm writing 2 here and 5 here. Tell me, instead of alpha 2 is there, instead of beta 5 is there. Tell me, students, how we need to write. X belongs to minus infinity to 2 union 5 to infinity. So this is the domain of f of x. Okay. Shall I move to the next one? See here. Domain of this function. Tell me, students, again this is under the root 2 minus mod x by mod x plus 1. This should be greater than or equal to 0. Say yes or no. Tell me the sign of mod x plus 1. What is the sign of mod x plus 1? It is always positive. So if denominator is positive, to make that entire fraction as positive, numerator must be positive. So I can write 2 minus mod x as positive, or you can equate to 0 as well. Numerator you can equate to 0. F of x can be 0, no issue. So 2 minus mod x greater than or equal to 0 in the sense mod x minus 2 lesser than or equal to 0. From this what you can say, mod x lesser than or equal to 2. When you remove modulus, you will get plus or minus 2. Then if you consider factors, you will get x minus 2 into x plus 2 lesser than or equal to 0. Yes or no? Or you can rewrite this one as minus 2 lesser than or equal to x lesser than or equal to 2. Okay. This one directly you can write like this. So minus 2 lesser than or equal to x lesser than or equal to 2 means x belongs to closed interval minus 2 to 2. That is directly the domain of given function f of x. Understand the students? So this is also a function under the root, fraction under the root, that model. Shall I move to the next one? See here, observe the base of logarithm and carefully find the domain of the function. So f of x is given as 1 by square root logarithm of x square minus 7x plus 13 to the base 1 by 2. So students, when base of logarithm is greater than 1, okay, then only you can say x is greater than 1 to define log x. If I'm saying log to the base, how much? 10. So 10 is obviously greater than 1. And if I say ln means base is how much? E. Here also E value is 2.732. This is also greater than 1. So in both cases, you can say x greater than 0. But when base is lesser than 1, in such case, to define this logarithm finitely, that value in the logarithm should fall in between 0 and 1. Then only it will define finitely. Otherwise, that function becomes undefined. So that is the condition we need to consider to find the domain of this function. Okay. So how to find the domain then? So x square minus 7x plus 13 less than 1. I considered. Then tell me x square minus 7x. If you send 1 to left side, what you will get? 12 lesser than 0. Then what are the factors of this? X minus 4, x minus 3. Now tell me x belongs to open interval 3 comma 4, which is the domain of given function. Okay, what is the point you learned from this question? If base of logarithm is lesser than 1, then the values of x under the logarithm should be lesser than 1. So here x square minus 7x plus 13 is given in logarithm. But here the base is lesser than 1. That's why I took x square minus 7x plus 13 less than 1. Remember, that point is very, very important. Shall I move to the next one? Yeah. So how to find the domain of this function? Is there any idea with you? Already here, base is 10 greater than 1. If base is 10 greater than 1, then that entire value should be greater than 0 or not? Yes or no? So I can consider log of log x to the base 10. Here also base 10. This value should be greater than 0. Then if I remove log, then what I'll get here? Log of log x to the base 10 greater than 10 power 0. 10 power 0 means how much? 1. So log of log x to the base 10, here also base 10, this should be greater than 1. Now again remove log. So log x to the base 10 greater than 10 power 1. So here log x to the base 10 greater than 10 power 1 means 10. Now again remove log. So x greater than 10 power 10. X greater than 10 power 10 means x belongs to 10 power 10 to infinity. That is the domain of this function. Clear? Okay, na? So how many logarithms they given? 4. Then how many tens we are getting? Base 10 na power 1. 2 tens. If 6 logarithms, 10 power 10 power 10. If 10 logarithms, 5. Like that you can. Okay, na? It is useful like a shortcut. Shall I move to the next one? See this question, students. Yeah, tell me, Sivakumar. Yeah, I'm saying that to define a logarithmic function with base 10, we are saying x should be greater than 1. So here, log of this entire function given to the base 10. That's why I considered log of log x to the base 10. This entire value is greater than 0. So 3 logarithms I took. That is also under the log. That's why those 3 logarithms I considered as greater than 0. Okay. Then after, you know this property, I think log x to the base y is equal to z means you can write x is equal to y power z. So that property alone I am applying. Here inequality sign is there. So here 10 power 0 you'll get, which is again 1. Like that I am removing one after the other logarithms. Clear as Shivkumar? Okay. Shall I move to the next one? See these questions, students. So in the numerator, logarithm value is given with base 2. Then definitely what you can say, x plus 3 should be greater than 0. In denominator, x square plus 3x plus 2 should not be equal to 0. Here x greater than how much? Minus 3. Can we factorize this? So you'll get x plus 1 and x plus 2. This should not be equal to 0. Then what you'll get, students? X should not be equal to minus 1 comma minus 2. So as I told, if the function is in the form of f of x by g of x, you have to find the individual domains for numerator and denominator. And then after you have to find the common interval. And from that common interval, you need to subtract the values of x, which makes the denominator 0. Yes or no? So what is the domain of x square plus 3x plus 2? All reals. It will satisfy for any real value. So consider a real number line, and in that real number line, if you consider the values of x which are greater than 3, then you will get this one as common part. Okay. From this common part, you have to exclude which values, students? Minus 2 and minus 1. Then finally, you can say domain is x belongs to minus 3 to infinite minus set of minus 1 and so better to write minus 2 and minus 1. Okay, I'm following number line order. Note down. This is also an important model. So actually, my target is to finish domain and range both. But only domain related examples I'm supposed to finish because of connection issue. So tomorrow means on Thursday, I'll come early to the classroom and I'll do the connections quickly and I'll finish range and types of functions concept as well. Okay, na? So as per the scheduled timetable, the lecture should be continued without any delay. And that is the reason why I came here. Okay, na? Your sir will come, no issue. This is a temporary class. Okay, na? Shall I move to the next question? You copied this one? Finished. Yeah, see this question, students. Domain of f of x is equal to root x plus 1 into x minus 3 by x plus 2. Students, for this question, you have to consider this fraction to be greater than or equal to 0. Okay. For that, I'm directly using sign scheme method. We can use no. So tell me the ascending order of critical points. Minus 2, minus 1, 3. Now, what is the leading coefficient? Positive. Numerator positive, denominator also positive. So entire value is positive. So consider plus sign here. And while you are crossing minus 2, what is the power of x plus 2? Odd. You should change sign. While you are crossing minus 1, what is the power of x plus 1? Odd. You should change sign. While you are crossing 3, what is the power of x minus 3? odd. So you have to change. So among these, you need to consider which region? Positive region. So you can say this entire expression is positive for minus infinity to minus 2 union. Students, if you consider closed interval at minus 2, yeah, tell me. I didn't get you once again. Here, you're saying this is plus minus like that. Yeah, if this is plus, then from here to here, what you will get? Negative. From here to here, positive. From here to here, negative. Then x belongs to. Students, can we take minus 2? We are not supposed to take minus 2. If we consider minus 2, that entire function defines, that entire function become undefined. So consider minus 2 at open interval. And minus 1 we can consider no issue. So closed interval union open 3 to, so closed 3 to 3 also you can consider closed 3 to infinite. Okay, I'll check the answer. Okay, once again, as of my remembrance, left to right. Once again, I'll check the answer. Once again, I'll check. Okay, boy, this is correct only. Correct only. Yeah, you can copy this.
Sir, whether are we supposed to put the signs from left to right or right to left?
Right to left. Let us verify. Verify by taking the value. If I consider x is equal to 4, tell me students whether this is positive or negative one. 5, 1, 6. You can verify by 6 is a positive. So right to left students, have a clarity upon that. Right to left. So in this region I'm taking minus 3 I'm supposed to take. Minus 2 into minus 5 by minus 1. So you are getting a negative. So this region you are having negative value. So right to left sign scheme. Okay. Shall I move to the next one? See this question, students. Domain of f of x is domain of f of x. He was asking sine of log of root 4 minus x square by 1 minus x. Sine of log of root 4 minus x square by 1 minus x. For this function, he was asking domain. Tell me, this root 4 minus x square by 1 minus x is in logarithm. So definitely you should say 4 minus x square, root 4 minus x square by 1 minus x should be positive. But you know, the output values of square root 4 minus x square is a positive result. Yes or no? That means numerator is positive. Then definitely denominator must be positive. And since it is in denominator, it should not be equal to 0 as well. So I can consider strictly greater than 0 for denominator so that it is not equal to plus 1. And for numerator also 4 minus x square. What you can say, it is greater than or equal to 0. If you put equal to 0, then you will get log 0. Log 0 is again undefined. So use a strictly greater than 0. Isn't it? In numerator under the square root 4 minus x square is there. So consider for 4 minus x square strictly greater than 0, and in denominator anyway 1 minus x is strictly greater than 0. Both numerator and denominator should have same sign. We already know that numerator is positive and hence I consider denominator as is also positive. Now tell me students, 4 minus x square greater than 0. For what? Strictly greater than only. So x square minus 4 should be less than 0. If x square minus 4 less than 0, then what you will get? X plus 2 into x minus 2 less than 0. Then from here what you can say, x belongs to minus 2 to plus 2. And here x minus 1 should be lesser than 0. Then x should be lesser than 1. So for these two you need to consider the common interval. So here minus 2, here plus 1, here plus 2. So x lesser than 1, minus 2 to plus 2 means you need to consider this region. So the common region is minus 2 to plus 1 in the number line. Therefore, x belongs to open interval minus 2 to open plus 1. Shall I move to the next one? Sine function no need to consider. That sine function actually it can take any reals, but instead of x we are having that logarithmic function. So the innermost values defines finitely, then entire function defines finitely. Since it is a composite function, I hope you know composite function. It is also one of the type we will discuss in the concept of types of function. Okay, so composite function means there are two functions f of x and g of x, and if we club those two functions then we will get f circle g of x, or we can club in another way which is called g circle f of x. Those are called composite functions. It is also in that form only. For composite functions we have to check whether innermost function defined finitely or not. If innermost function defines finitely, then entire function defines finitely. Shall I move to the 12th question? Finished? Let us see this question, students. There is a function y is equal to f of x, which is satisfying this relation. E power x plus e power y is equal to a. So we have to consider this relation in the form of y is equal to f of x function. So I'm sending e power x to right side. Now e power y is equal to e minus e power x. So yes or no? How I can write it in the form of y is equal to f of x form? By applying logarithm or not? So if you apply log on both sides, log of e power y is equal to log of e minus e power x. So log e power y value by, because log a power x to the base e can be written as x into log a to the base e. Yes or no? X into log a to the base e. You can write this exponent x as a product of log. So in the same way, if you consider this y here, y into log e to the base e, with respect to e I am applying. So this is log of e minus e power x to the base e. So this value anyway it will become 1. So y is equal to log of e minus e power x you will get to the base e, means e minus e power x should be greater than 0. Then e power x minus e should be less than 0. If you are interchanging, if you are multiplying with negative sign, inequality sign should change from greater than to lesser. So e power x should be less than e. E means e power 1. So e power x less than e power 1 means x should be lesser than 1. Then domain of this function is x belongs to minus infinity to 1. You can copy quickly, students. I'll move to the next question. Nivashanin. Present absent. Nivashanin. Correct pronunciation. Nivashanin. Yeah, I'm moving to the next question, students. See this question. Domain of f of x is equal to logarithm of root x minus 4 plus root 6 minus x to the base 10. Tell me, here this is f of x, this is g of x. Both are added and it is under the log. Now, to define f of x, x minus 4 should be greater than or equal to 0. X should be greater than or equal to 4. To define g of x, 6 minus x should be less greater than or equal to 0. Then x minus 6 lesser than or equal to 0. Then x is lesser than or equal to 6. So this entire value f of x plus g of x, it is always positive, just yes or no. So it is satisfying logarithmic property. So just find intersection of these two. What is the intersection of x greater than or equal to 4 and x lesser than or equal to 6? X belongs to closed interval 4 comma. So that is the domain of given function. Clear, students? Clear? Shall I move to the next one? See this question. Students, have you heard about greatest integer function? Step function. What is the step value of 2.5? What is the step value of minus 2.5? Minus 3. Very good. So f of x is given as 1 by root step x square minus step x minus 6. Since it is under the denominator and again it is under the square root, what is the condition you have to consider? Step x square minus step x minus 6. This should be strictly greater than 0. Now I'm doing factorization by keeping step x as it is. So what are the factors? Step x square minus, this can be written as minus 3 into step x plus 2 into step x minus 6. This is greater than 0. So I'm going to take step x as common. Then what you will get? Step x minus 3 and plus 2 as common. Then again what you will get? Step x minus 3. This is strictly greater than 0. Again, can I take step x minus 3 common? So then you will get like this. Now, step x plus 2 we are getting. I'm just rewriting like minus of minus 2 and here step x minus 3. This is strictly greater than 0. So this can be written as step x belongs to minus infinity to minus 2 open interval union 3 to infinity. So this is not the domain. This is step x values. To find the domain, we need to find x values, remember. Just I identified the integer values of x belongs to which particular interval. Then for what values of x, these kind of integer values we will get. That's what we are supposed to find. Okay. So from this, to find the values of x, think about extremities first. Are we considering minus 2? Minus 2 is an integer. Are we considering minus 2? No. If I consider minus 2.1, which type of integer I'm getting? Step of minus 2.1 means what is its value? Minus 3 is in that interval or not? Minus 3 is in that interval or not? Then obviously you can consider in the left leg of this interval minus infinity to minus 2. Because minus 2.1, if you consider the value of x, then what is its step value? Minus 3. Minus 3 falls in that above interval or not? Then you can consider the left leg as minus infinity to minus 2. Then right side. What is the step value of 3.1? 3. Are we considering 3 in the step value? Step interval, step value interval? No. Then if I consider 4, 4 is in step functions. Yes or no? In that step interval, 4 is there because step value of x belongs to minus infinity to minus 2 union open 3 to infinity. In open 3 to infinity, 4 is there. Yes or no? Then 3.1, 3.2, 3.3, all these x values omitted. Then from which value of x we need to consider? 4 onwards. That means in the right leg, a closed interval 4 to infinity. Understand now? So just by focusing on the extremities of step function, you can write the values of x. Okay. So this is the domain of the given function. Clear, students? If you're having any doubt on writing the x values, you can ask me once again because this model is very, very important. If it is clear, copy quickly. I'll move to the next question. I am a That's why that person is laughing. Huh? You boy. Up to 8:40, 8:30. Yeah. 8:30 only, na? Yeah, copy this question and I'll leave. I'll continue from Thursday onwards. Okay. Yeah, online students, thank you all of you. You can leave now.
Thank you, sir.
Thank you, sir.